Hey guys, it's Shona and I'm back. It's been a long time since you have seen me, but believe me, I'm gonna make it up to you. So let's not waste the time and start the video. Here comes our intro. So guys, today we will mainly discuss about two topics. First will be force and the second will be the laws of motion. What is force? In physics, a force is any interaction that when unopposed will change the motion of an object. In simple words, the push or pull on an object with mass that causes it to change its velocity is called the force. Forces has been divided among two major groups. The first one is contact forces and the second one is non-contact forces. Contact forces include muscular forces, frictional forces, normal force, applied force, tension force, and spring force. Air resistant force is also included in it. Non-contact forces include gravitational force, magnetic force, and electrostatic force. Let's see an example of each type of forces. Breathing is a pretty common example of a muscular force. Lighting a matchstick is also an example of frictional force. Theoretically, the normal force is the component of a contact force that is perpendicular to the surface that an object contacts. So, when you are on an elevator and the elevator moves upward, you feel your weight to be increasing. That's because the normal force is acting against the gravity and upon your mass. Applied force is pretty similar to the muscular force, but it is the force which is applied to a person or an object, such as pushing or pulling. For example, when you are pulling or pushing a table, it is said to be applied force. The force experienced by the cables of a suspension bridge is said to be the tension force. Force exerted by a compressed or stretched spring is called spring force. Air resistance force is the force which is experienced by an object while moving in air. Water droplets falling down during a rain can be said to be an example of gravitational force. Forces exerted by a magnet on magnetic objects such as metals are called magnetic forces. The types of forces exerted by all electrically charged bodies on another charged body in the universe are electrostatic forces. So, what is the Newton's law of motion? Newton's law of motion are three physical laws that together laid the foundation of classical mechanics. They describe the relationship between a body and the forces acting upon it, and its motion in response to those forces. More precisely, the first law defines the force qualitatively, the second law offers a quantitative measure of the force, and the third asserts that a single isolated force does not exist. These three laws have been expressed in several ways over nearly 3 centuries and can be summarized as follows. First law, in an inertial frame of reference, an object either remains at rest or continues to move at a constant velocity unless acted upon by a force. The second law, in an inertial frame of reference, the vector sum of the forces on an object is equal to the mass m of that object multiplied by the acceleration a of that object, that is F equals to ma. And the third law, when an object exerts a force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction on the first body. So let's dive into the Newton's first law. The first law states that if the net force is 0, then the velocity of the object is constant. Velocity is a vector quantity which expresses both the object's speed and the direction of its motion. Therefore, the statement that the object's velocity is constant is a statement that both its speed and the direction of its motion are constant. The first law can be stated mathematically when the mass is a non-zero constant, as sigma f equals to 0, that is, dv by dt equals to 0. Consequently, an object that is at rest will stay at rest unless a force acts upon it. Similarly, an object that is in motion will not change its velocity unless a force acts upon it. This is known as uniform motion. An object continues to do whatever it happens to be doing unless a force is exerted upon it. If it is at rest, it continues in a state of rest If an object is moving, it continues to move without turning or changing its speed. That is evident in space probes that continuously move in outer space. Changes in motion must be imposed against the tendency of an object to retain its states of motion. In the absence of net forces, an moving object tends to move along a straight line path indefinitely. Newton placed the first law of motion to establish frames of reference, for which the other laws are applicable. However, Newton implicitly referred to the absolute coordinate of cosmos for this frame. Since we cannot precisely measure our velocity relative to a fast star, Newton's frame is based on a pure imagination, not based on measurable physics. In current physics, the observer defines himself as an inertial frame by preparing one stone hooked up by a spring and rotating the spring to any direction and observing the stone static and length of that spring unchanged. By Einstein equivalence principle, if there was one such observer A and another observer B moving constant velocity related to A, then A and B will both observe the same physics phenomena. If A verified the first law, then B will verify it too. In this way, the definition of inertial can get rid of absolute space and far star and only refer to the objects locally reachable and measurable. A particle not subject to forces move in a straight line at a constant speed. Newton's first law is often referred to as the law of inertia. Thus, a condition necessary for the uniform motion of a particle relative to an inertial reference frame is the total net force acting on its zero. Inertia is the resistance of any physical object to any change in its velocity. This includes changes to the object's speed or direction of motion. An aspect of this property is the tendency of objects to keep moving in a straight line at constant speed when no forces acts upon them. Inertia comes from Latin word iner, meaning idle, sluggish. Inertia is one of the primary manifestations of mass, which is quantitatively property of physical systems. Isaac Newton defined inertia as his first law in his Philosophia Naturalis Principia Mathematica. Let's see some examples of inertia. Thank you guys for watching this video. Please don't forget to like, share and subscribe. And don't forget, today's readers can be tomorrow's leaders.